The second learning objective from section 3.2 is to find and interpret the z-scores for individual values. Let's first write out the formula for a z-score. It is z equals x minus mu over sigma. Let's look at an example. The time to run a mile for 14-year-old boys is bell-shaped with a mean of 464 seconds and a standard deviation of 88 seconds. Marco ran the mile in 425 seconds. Compute and interpret his z-score. Well, let's identify the values that we need. 464 is the mean of the population, so that's mu. 88 is the standard deviation of the population, that's sigma. And 425 is Marco's data value, so that's x in our formula. So we can compute this. We're going to take Marco's time, 425, subtract off the mean of the population, 464, and then divide by the standard deviation of the population, 88. We can do this calculation in any calculator. You could do it in GeoGebra as well, but I've got a calculator here. So I'm going to do the numerator, 425 minus 464, and I'm going to hit enter before I do the division. We're going to follow order of operations, and you can think of that numerator as being in parentheses. So I do that first, and then I'm going to divide by the standard deviation, which is 88, and I get a z-score of negative 0.44. So there's his z-score. So I've determined that the answer has to be A or B, since those are the two that have negative 0.44 as the z-score. The interpretation for the z-score is that it gives us the number of standard deviations between the data value x and the mean mu. So in this case, Marco's time to run the mile of 425 seconds is 0.44 standard deviations below the mean. The negative in front of that z-score tells us that we are below the mean. When you're running a mile, having a lower time means that you are faster. So Marco's z-score is negative 0.44, which means he ran the mile 0.44 standard deviations faster than the mean. Let's look at another example. The mean lifetime of a tire is 30,000 kilometers with a standard deviation of 60,000 kilometers. Which of the following is the correct statement about a tire that lasts 38,700 kilometers? Well, let's compute a z-score again. Our data value here is 38,700. The mean is 30,000. And our standard deviation is 6,000. And if we do this calculation, $38,700 minus 30,000, enter, divided by 6,000, I get a z-score of 1.45. My z-score is now positive, which tells me that my data value is above the mean. You can see that 38,700 is higher than 30,000. So that's a good way to check yourself to verify that you're ending up with a positive value if your data value is higher than the mean and a negative value if your data value is lower than the mean. And now we know that a tire that lasts 38,700 kilometers is 1.45 standard deviations above the mean.